Probability density function. It is important to note that since the variable is continuous, there are an infinite number of individual values that could be taken. Thus, as mentioned earlier, the probability of any single value being taken is 0. Hence, if you are asked for the probability that x is equal to 3 for a continuous random variable x, you will always write the probability that x is equal to 3 is 0. We can, however, talk about the probability that x takes a value in each range as we did in example 1. This gives us the idea of probability density, i.e. the likelihood that x lies between two values. Typically, the graph of a PDF is a curve, and the total area under the curve is always 1. So we might have a curve like this. So our probability function is f of x, and in this region here, it takes non-zero values, and it will take 0 values either side of a and b. Consider the shape of the function p of x above. Suppose we had a value h close to a. From what we have discussed, the probability of x being equal to h is 0. So remember, h is down here close to a, and we're going to talk about another value up here where we can see the curve is higher. So we have another value k which is close to b. We know that the probability that x actually being equal to k is 0. However, the shape of the distribution shows that it is more likely that an observation from this distribution would be in the vicinity of k than in the vicinity of h. The probability of being in the vicinity of h is given by the area shown around x equals h, and the probability of being in the vicinity of k is shown by the area shown around x equals k. If the areas have the same width, it should be clear that the area around k is greater. We could state the probability density function as f of x is p of x between a and b, and 0 otherwise. As mentioned, the probability would be 0 here and here. Or f of x is equal to p of x for the interval ab, and is 0 for any other value of x. And remember from our discussion of intervals that it doesn't matter whether we have square brackets or not. If we wanted the probability that the variable was to take a value between, say, c and d, in other words, we're talking about this area here. If we know p of x, we can calculate this using an integral, the integral from c to d of p of x dx. Any probability density function must satisfy the following conditions, and you'll see here that there are direct analogues to discrete random variables. First of all, p of x must be above the axis, or on the axis, for all values of x in the interval. The integral between a and b, for p of x, where it takes these non-zero values, or possibly 0, must be equal to 1, and that's because we know that the maximum probability is 1. We may see questions where we're asked if a given function could be a PDF. So it has to satisfy both of these conditions. And always check this first one first, because it's the easiest one to check. If the curve dips below the axis, it can't be a PDF.